Hi, and welcome to Thursday's Maths with Kirin session. So Thursdays are an opportunity for people to send through some questions that they might be having trouble with, and I can work through them. So I've got 5 questions to go through with you today. All of them are from old exam papers, and they cover the content that we've been through in the previous 7 lessons. So we'll just straight to it. Just as I go through these, if you have any questions about what I'm doing or why I've done something, feel free to ask them. There might be a bit of a delay between I see your question and when you've written it, but I will see it pop up and I can go through those as we go. So first question here is from 2017 paper. Leo is laying square concrete tiles for his deck. He starts with laying them down to form a square pattern, but his friend thinks it would be better if they were laid out to form a rectangle. He changes his layout to make the length of the deck 8 tiles longer and the width of the deck 4 tiles shorter. He finds he needs 2 extra tiles to complete the rectangular pattern. How many tiles did he have to start with? So we've got lots of information. You might need to read through this a few times in order to get everything that you need to answer the question. So the key things that we are sort of dealing with, we started with a square pattern and then we change it to a rectangular pattern. When we change it to the rectangular pattern, we have the length 6 tiles longer and the width 4 tiles shorter. Okay, and when we do that, we're going to need 2 more tiles in order to get that rectangular pattern filled out. How many tiles do we have to start with? So it might be a good idea to start with just some diagrams so you can sort of get your head around what we've got. So if we have our square that we start with, we don't know the dimensions of the square, so we might just say it's an x by x square. Okay, you might not use x, you might use n or a, whatever it is that you want to use, or t for tiles. I'm just going to use x by x. So that's our square. When we change to the rectangle, we have a different shape, obviously a rectangular shape. The length is 6 tiles longer, so what we had before was x, so we need to add 6 more tiles. And the width, they said, is 4 tiles shorter. So we started with x, we need to take 4 away to get 4 tiles shorter. We want to know how many tiles we have to start with, bearing in mind that this takes 2 extra tiles than this. Okay, so we need to form an equation, and then we want to solve that in order to figure out the tiles. So the number of tiles here is the same as the number of tiles here, except this has 2 extra. So if we think about the number of tiles, to get the number of tiles for a rectangle, we have x times x, which is x squared. To get the number of tiles, number of tiles for a square is x times x, squared. The number of tiles for a rectangle is base times height. So we've got x plus 6 times x minus 4. Now we know that this has 2 extra tiles. So in order for these to be equal, there's 2 things we can do. We can either take 2 tiles off this in order to get them equal, or we can add 2 tiles to the square in order to make them even. So if we have a plus 2 here, we know that this is now going to be the same as this. Okay, we have to add 2 extra tiles that we had for that rectangle. Cool. So from here, we want to expand. Looks like we've got a quadratic. So to solve a quadratic, we would expand, make it equal to 0, and go from there. So let's see what happens when we expand and simplify. So x squared plus 2 stays the same. When we expand, we get x squared minus 4x plus 6x is plus 2x, and then 6 times negative 4 is negative 24. Okay, so you'll see we've got a common factor, or common term of x squared. So when I take my x squared to the left-hand side and subtract it, we have no more x squared terms, which means we don't actually end up with a quadratic, even though that's what it looked like to start with. We're going to end up with a linear equation. Okay, so if you bring your 24 to the left-hand side and we add it to the 2, we get 26. X squared and x squared, well, they cancel each other out, so we are left with 2x, which means x is equal to 26 divided by 2, which is 13. Okay, and it pays to go back and make sure that we've answered the question. So x is 13, which means the dimensions of the square are 13 by 13, and we could work out the dimensions of the rectangle. The question is asking how many tiles did he have to start with. So if this is 13 and this is 13, then the number of tiles would be x squared, which is 13 squared. So we've got 13 times 13. So to do that, I would go 10 times 13 plus 3 times 13. So remember, you're not allowed a calculator, and I don't happen to know 13 times 13 off the top of my head. But doing it this way makes it a little bit easier. So 10 times 13 is 130, and then 3 times 13, or 3 times 10 is 30, and then 3 times 3 is 9, so 39, and when we add those together, we get 159. Okay, so to answer the question, originally he had 169 tiles, which means with the rectangular pattern he would need 171, 2 extra. That's 159. So for achieved, you can set up your equation. So remember, you can either have x squared plus 2 equals x plus 6 times x minus 4, or you might write it as x squared equals x plus 6 x minus 4 minus 2. Okay, either of those are fine. Or you might simplify your equation to get your sort of quadratic, and then move that down into your linear equation. Or you might set up your equation with this, so your x plus 6 and your x minus 4, and consistently expand it to get your quadratic and simplify the quadratic. Or you consistently solve your equation. So when they say consistently, something's gone wrong. Maybe you made an error in your expansion, but you consistently work that through and you solve your equation. So any of those things, for achieve. For merit, you need to do 2 of those things. So set up your equation and get to your linear, the 26 to x, or set up your equation and expand this and simplify it, that kind of stuff for merit. And then for excellence, you get all the way through, so you'll need to find your x, and you also need to find the number of tiles that they're asking for. 169 tiles to start with. Cool. Moving on to question number 2. So the second question comes from the 2016 paper. This is similar to what we were looking at yesterday in that lesson 7, so exponential equations, because we've got power. So the question is asking if n is a whole number, find the values of n, or for what values of n is 6 times 2 to the power of n plus 1 greater than 123. So similar to the questions yesterday, but this one's a little bit different because in all of the questions that we had that looked like this yesterday, we were able to rewrite this with 2 as a base, and then we could use our algebra rules to simplify. You can't write 2 to the power of something to get 6. It doesn't work. So what we're going to do is we're going to divide 123 by 6. It doesn't fit perfectly. We'll end up with a decimal, but we will still be able to solve it from there. It just might not look as tidy as today. So we get 2 to the power of n plus 1 is greater than 123 divided by 6. Okay, and if we simplify that, 6 goes into 12 twice, and doesn't go 3, and with our remainder we end up with 20.5. Okay, or you could write that and just simplify your fraction if you want to. 20.5 is probably a little easier to understand. So 2 to the power of n plus 1 has to be greater than 20.5. Now we might remember from yesterday, if we don't work it out, 2 to the power of 4, 2 times 2 is 4, times 2 is 8, times 2 is 16. And 2 to the power of 5 is therefore 32. Now we need 2 to this power to be bigger than 20.5. So that means that n plus 1 has to be bigger than 4, or you could write n plus 1 is bigger than or equal to 5, remembering that we're told n has to be a whole number. Okay, so if you write this, when you solve it, n has to be bigger than 3, or if you prefer this expression, n has to be bigger than or equal to 4. Okay, either of those are fine. So for achieved, you simplify your inequality, or you correctly trial at least one number. So you just substitute a number in n and see what happens. So kind of using trial and error. Or if you write your correct answer only, that was enough for achieved. For merit, you have a consistent solution from incorrect working. So maybe you did your divided by wrong here. but you consistently solved from that error, that would give you merit. Or you might write n is equal to 4 instead of having the inequality as your solution, or you might write n is greater than 4 without the equal to. So those things would give you merit. Or if you correctly simplify, but you miss in your solution this whole +1 here, and then for excellence, you get all the way through with your correct solution. Okay, so either this or this, you don't need both, one or the other. Running on. Question number 3, also from the 2016 paper. So this one has a little picture with it. Raj kicks a ball. The flight path of the ball can be modelled by y equals negative, and then in brackets x squared minus 4x, where x and y are measured in meters. The first part is asking us what does x measure. So they've given you this diagram. So we've got our y-axis and our x-axis. So x is the horizontal distance that the ball travels from where it was kicked. Okay, so the horizontal distance the ball travels from where it was kicked. Okay, so that's an achieved question. You need to identify what x is, but you need to make sure you do it in context. So we're talking about that horizontal distance that the ball travels from where it was kicked. Cool. The second part of the question. For what percentage of the horizontal distance that the ball travels will it be 3 meters or more above the ground? Okay, what percentage of the horizontal distance that the ball travels will it be 3 meters or more above the ground? So we need to work out two things in order to calculate the percentage. We need to work out the total distance, the total horizontal distance that it travels, but we also need to work out the distance that it travels when it's 3 meters or more above the ground. Okay, so we'll start with the 3 meters or more above the ground. So I'm just going to use another piece of paper, but I'll just leave it so we can still see this equation. So 3 meters or more above the ground means that our equation, our negative bracket x squared minus 4x, needs to be greater than or equal 3. Okay. So if we sort of expand it out, we get negative x squared plus 4x is greater than or equal to 3. Bringing our 3 across, it's a quadratic. Negative x squared plus 4x minus 3 has to be greater than or equal to 0. Factorizing is tricky with a negative. It is possible, but most of the time people prefer to have a positive. So we're going to multiply through by -1, which means all of our signs change and our inequality needs to reverse. Okay, so now we're looking for less than 0. So when we factorize this, we've got x and x. 3 and 1 are the only numbers that work, and we want -4, so -3, -1. So our critical values are when this expression is equal to 0, so x is +1 and +3. Okay. We want it to be less than 0. We have, when we're solving this equation, a positive parabola, so remember it's going to be going this way, which means it's going to be less than 0 between 1 and 3, which makes sense because we're saying for this particular graph, if let's say this is our 3 here, and this 1, and this would be 3, and so our ball is 3 meters or higher between +1 and +3. Okay. The next part we need to work out is the horizontal distance that it travels in total. So that means we still need to use our equation. So we're looking at total horizontal distance. All right, so we have our equation. Total horizontal distance, well, when we start, the distance is 0, and when we finish, the distance will be 0. So we find that by making this equation equal to 0. So to solve it, bring it out of the brackets. It's already equal to 0, so we factorize. If we take x, we can take negative x out of the brackets. We have x minus 4 equals 0. So our two solutions, this up, either x is 0 or positive 4. Okay, so that means that on our diagram this is 0 and this point here is 4. I haven't really scaled very well. So total horizontal distance is 4 meters. Okay, and then we know that it's 3 meters or more between 1 and 3. So 3 meters or above. Between 1 and 3. So it occurs for 2 meters of length. So to work out our percentage, 2 meters of distance travelled when it's 3 meters or more above the ground, divided by the 4 meters that we have of total distance, multiplied by 100, will give you 50%. You don't have to show that calculation. I'm thinking most of you will be able to see 2 out of 4 is going to be 50%. Okay, that's how you would get that. It wasn't quite so easy to see. So answering the question, for what percentage of the horizontal distance that the ball travels will it be 3 meters or more above the ground? 50%. So for this question, a little bit of working. For achieved, you equate your first relationship to 3. Okay, so you don't even have to do it as an equation. You can just make it equal to 3. That's fine. For merit, you solve this to get your 1 and 3. And again, you could have equals here. You don't have to solve it as an equation in order to get that merit mark. So 1 and 3. For excellence, you calculate your percentage, showing some working. And again, you might have equal signs here. That won't stop you from getting excellent either. Okay, so solving to get your 1 and 3, and then solving to get your 0 and 4, and getting that 50%. It does say in the marking schedule that if you wrote 50% as a fraction, so half, or you wrote it as a decimal, you still get the excellence grade. Okay, so even though the question is asking for a percentage, if you did happen to leave it as a fraction or write it as a decimal, you would still get 4 marks for this question. Okay. Got 2 more questions to go. So the 2015 paper. Danny is trying to find a value for C so that x squared plus 6x plus c equals 0 only has one solution. Find the value for C and the solution to the equation. Okay, so we've got x squared plus 6x plus c is equal to 0, and we only want one solution. So we know when we solve a quadratic, we want to factorize it. And then we make each factor equal to 0 in order to solve x. If there is only one solution, then if we just say this is plus a and plus b, for only one solution, a and b have to be the same. Okay, the only way that we could get the same solution. So we know that a and b have to be the same. They have to add to give us 6. A plus b needs to give 6, but we know that a and b are the same. So the only way we can get two numbers that are the same, give us 6, would be if a and b, these 3 dots, if you see them, mathematical notation, I guess, for therefore. So if we have a is equal to b and a plus b equals 6, therefore a equals b equals 3. So when we factorize up here, we get x plus 3 because we want positive 6. Okay, so the question is asking us to find the value for C and the solution to the equation. So the value for C, we haven't actually found that yet. We would find that by expanding this. So 3 times 3 will give us the value of C, which means C is equal to 9. And the solution for the equation, if we solve this, the solution, x is equal to negative 3. So for this question, if you show factorising as a perfect square. This is called a perfect square because technically we could write it like this. Because it's the same thing multiplied by itself. All right, so if you can have some evidence to show that you know you're looking for a perfect square, then that will give you achieved. Okay, because that's how we get one solution. For merit, the value of your constant is found, so you find that the C is equal to 9, or the solution for your perfect square without giving the value of the constant. So you might say that x is equal to -3, but you forget to say C is equal to 9. So you either find C or you find x. That will give you merit. For excellence, you need to find both. The value of C and the solution to the equation. The value of x, and that will give you excellence. Cool. One last question for today. Again, from the 2015 paper, and quite a lot of information. So if we read through it first to make sense of what's going on, and then we'll see if we can solve it. So, Cherie has had an operation and needs to build up her strength by walking. She slowly increases the time for which she walks. She wants to increase the time for which she walks to 160 minutes each day. The first week, she goes for a 10-minute walk each day. Each Monday, she doubles the time for which she walks each day. The time for which she walks each day in week n can be modelled by the equation t equals 10 times 2 to the power of n minus 1. How many weeks will it take her to reach her goal of walking for 160 minutes a day? Lots of information. She's walking, she's increasing it, she wants to get to 160 minutes a day. That's important. All of this information they've told us, but they've already put it into an equation for us. Okay. The question is asking how many weeks will it take for her to reach her goal of walking for 160 minutes a day. Okay, so we know that this is the equation for the time in which she walks each day. So we want this to equal 160. So 10 times 2 to the n minus 1 needs to equal 160. Okay, so again, the first thing that I would look for to make it nice and tidy is whether I can rewrite this with a basic 2, and then I can simplify those exponents. Unfortunately, I can't. You can't have 2 to the power of anything to give us 10 or anything that's a whole number. So the next thing that we'll need to do is take our 10 and move it across to the other side of the equation by dividing. Now, conveniently, you can divide 160 by 10 quite easily. So we get 2 to the power of n minus 1 is 160 divided by 10. So 2 to the power of n minus 1 is equal to 16. Okay. So from here, we already know that 2 to the power of 4 is equal to 16. Okay, we've kind of learned that. We've seen that a couple of times over the last couple of days. So that means that n minus 1 has to be equal to 4. So n has to be equal to 5. Okay. So for this question, for achieved, you simplify your equation or an equation. So you might divide through by 10 to get to this here. That will give you achieved. For merit, you solve your equation. So they either accept n equals 5, or you might write after the 4th week. Okay, so the 5th week will get her the 160 minutes that she wants, but that would also be after. Okay, and I think the question says how many weeks will it take her to do that? So 5 weeks or after the 4th week. Cool. And merit is as high as you can go for that particular question. So those were all of the questions that I had to go through today. So just remember, if you do come across something when you're doing some study for your algebra and you're not quite sure how to solve it, or even if you're just not quite sure what the marking schedule is trying to tell you, then email or message me and I will quite happily be able to go through that on the Thursday session. So my email is just up here. If you would like to use that, or message me on the Facebook page, that would be perfect, and I will get that for you. The schedule for next week, so Monday we're looking at substitution and rearranging expressions, and then on Wednesday next week solving simultaneous equations just using substitution, and then the following Monday we'll still be looking at simultaneous equations but using elimination. I've just split that into two, just to make that a little bit less content in one session. So, well, thanks for joining me today. For those people watching live, for those of you who might check this out later on YouTube, feel free to join a live session. So Mondays, Wednesdays at 5:30, I go through a lesson, and Thursdays at 5:30, I go through just some questions that people have sent through, and want a little bit of help with. So joining live and ask questions as I go through the session if you want to. If you're watching on YouTube and you don't quite understand something that I've been through, then again, put me a message or an email, and I can try and sort that out for you. Otherwise, have a lovely weekend, and I hope to see you on Monday.